Hey everybody. Hope this Ed puzzle thing is working out for you. Hope you're able to watch these videos and slow them down and pause them as need be to take notes. It seems as though we've gotten a pretty good response so far. I wanted to take a few minutes to go over the next group of problems that I asked you to do, numbers 7 to 14. A lot of people had questions with a few of the last, like numbers 13 and 14, so we'll definitely make sure we touch on them as well. I also included an extra practice problem that we'll do in a few minutes. All right, so if you notice, what I did here was we're trying to use that Pythagorean identity, okay? So we're trying to get ourselves to the point where if we see the 1 minus sine squared x, like we do here in this case, we know that equals cosine squared x. All right, so it's always good to kind of take a look at the problem and kind of assess it really before you dive right into it. All right, take a look to see what you're trying to get it equal to. Take a look on that right side of the equal sign as well. And once we rewrite it as cosine squared x, we know that x squared and x squared multiply to give us cosine x to the fourth, or cosine 4x. In number 8 here, this is the identity in itself. We said that we could kind of use this in different ways, and I talked about manipulating this yesterday. But right on your identity sheet, sine squared x plus cosine squared x is 1. Not sure if you can hear my daughter in the background, but she's saying hi. Hey, Liv. And we know that the reciprocal identity, 1 over secant x, is the equivalent to cosine x. So again here, here's this Pythagorean identity just rewritten. So picture like up here, if we had this, we know is equal to 1. If I just subtracted sine squared x over, or I subtracted cosine to the other side, it would be sine squared x equals 1 minus cosine squared x. So that's where I was able to come up with this. It's just us taking this identity over here and rewriting it a couple different ways. Sine over cosine, we know is tangent. Very similar to this, right, is the same idea, us manipulating this Pythagorean identity. Think of this as like x squared over x. You would just be reducing. You would be subtracting the exponents, right? And that's what I did here to simplify it down to cosine x. All right. I added this quick practice problem. I'll come back to that in a second. But before we do that, because that one kind of looked like I thought like number 13. So if we got stuck there, I want to maybe show you a little practice problem before doing that. But looking at number 11, here are the problems where we need to factor. And there's 2 ways in which you're going to be asked to factor. You're either going to have to first take out a GCF, which I would look to think, okay, can I do that first? And if you can't, then it's, okay, is it the difference of squares? So sine x and sine cubed x, a common term would be sine x. If we factor that out, here's what we would have left, okay? And we know that, well, sine and sine would cancel. This right here, again, that Pythagorean identity is cosine squared x. In number 12, difference of squares. Just think of this as like x squared minus y squared. But instead of x and y, you kind of have like sine and cosine. But it's the same idea. It's sine x plus cosine x and sine x minus cosine x in no particular order. Once you kind of factor it, this would cancel, this would cancel. All we're left with is what we needed to verify in the first place. All right. Very similar to that problem was number 14. In number 14 here, again, difference of squares, just rearranged. But again, you factor it, you'd cross out these common terms, and you're left with cosine x plus sine x. Okay. So with these problems, when it comes time for us to take another quiz, or as you're submitting these problems as you do them, make sure you show the work, and you're showing the steps as you go. Now, I think we had most of our questions came with number 13. So before we get there, let's kind of do this practice problem that I included here. Okay. So this might not look, like it could be factored, but just think, this is a term and this is a term. Okay. Think of it almost like, 2 minus, 4x. you could factor, a 2 out, a common term, right? So you're looking for GCF, greatest common factor, and they both include sine. So we're going to factor out sine x. And in doing so, we would have 1 minus cosine squared x. Oops. Now, as you do this, you can't be afraid to try things. You can't be afraid to say, okay, well, let me try doing it this way, see where I get, especially as we get to further down the road here with some more challenging problems. But we can't be afraid to try. And in doing so, maybe you factor out that sine x, and you're like, all right, well, I'm not sure if this was the right thing to do. However, if I quickly now just redistribute that sine x, I would, in fact, get what I started with. So we probably did the right thing. So again, think of this as just reducing, reducing like terms. I saw some people do that. I saw some people maybe just say, well, hold on a sec, 1 minus cosine squared x. I know that this right here equals sine squared x, that Pythagorean identity. All right. So picture this, not here anymore because we just made that sine squared x. Well, now we have these that would cancel, and we have got what we needed to verify it to, sine x. All right. All right, guys, last problem. You're doing well. Thanks for bearing with me here. So in number 13, same idea. We're going to factor out a cosine. Okay. What we're left with then is 1 minus sine squared x. Now, I went about this one a little differently, just so you see it. Before I converted this, I said, well, let's just kind of reduce, cosine, and let's drop this down to just cosine x. And then I knew that, well, wait, this right here is cosine squared x, which again, reducing those exponents, I was able to just come away with cosine of x. All right. So to just sum things up, what we've done so far is we've kind of touched on these reciprocal identities. If you look on the left-hand side of your screen, the quotients, and this one Pythagorean. All right. And I think more importantly, it's the methods that we need to try to understand how to go about these. The first thing we need to do is try to rewrite in terms of sine and cosine. And now what we've focused on the last few days, or the last day or two, is factoring. Okay. I'm going to submit another video later today that you can kind of take some time over the weekend to just watch, and that would be finding the common denominator, which is going to be a little more challenging, especially for me as I try to write with this with the tool here. But make the best of what we got. Thanks, guys, for tuning in and giving me your attention and trying these problems. Appreciate all the effort. Hope everybody's staying healthy, and talk to you guys soon. Thanks.